Assalamualaikum and hello students. Let's continue with part 3 of module 5. In part 3, you are going to learn about dual symbol. Remember this from module 4? This is when we learn about De Morgan. There are physical gate and logical gate. In here, in module 5, we call it dual symbol. Yeah? NaN can be represented in a different way. So what is NaN if I consider this as AB? So this is AB bar. This will be A plus B bar. N become OR, yeah, and the bubble after becomes bubble before. Same thing with NOR. You've got this. Converting NaN and NOR to dual symbol, NaN to negative OR, NOR becomes negative AND. Why do we have dual symbol? Why do we have alternative representation? We use it just like De Morgan. We use it to simplify our circuit to get the best circuit using the least number of gate, yeah, to simplify our circuit. Let me show you an example. So this is the original gate. All right, this is the original gate. This is actually the sorry, there's a bubble here. Yeah, this is the original gate. But by looking at this, you have to maybe convert this into a Boolean expression and then try to use all those Boolean algebra, De Morgan, whatnot, trying to solve it. But if you change this NAND gate to its equivalent dual symbol, which is this, it becomes negative OR. They are the same. Yeah, one is logical, one is physical. Now you can see it becomes so much easier to simplify. You don't have to convert to Boolean expression. Look, there is a gate here. Oh, sorry, there's a wire here. And two bubble at the two ends. When two bubble meets, just like when I teach you previously in the previous video, you can bar, you can cancel it out. You can cancel them out. This one, yeah, cancel them out. Same thing with this, cancel it. Because A bar becomes A bar, you bar it again becomes A. So why do you need the two bars? The two bar can be cancel out, bar, bar. Yeah? So cancel out. Now the drawing becomes 1, 2, 3, 1, 2. No more bubble there. That no longer become NaN. And now this is in OR logic. So that's why we use dual symbol. So same thing with the second diagram here. So what is this? We are converting SUP circuit to NaN only. Okay. In the previous slide, I show you from basic gate to I show you from NAND gate using NAND universal gate only, and then I convert it to dual symbol to negative OR. We got our basic gate. Now the opposite, having basic gates of an OR logic, yeah, please convert this circuit to using NAND only, universal gate only. How do we do it? This is how we do it. This is how we do it. In the previous slide, we cancel out the bubble. In this slide, because we're doing it reverse engineering, we are going to introduce the bubble. We need to introduce two bubbles because two bubbles can cancel out, meaning we didn't change the value. Do not introduce odd number of bubbles. Do not introduce one bubble, three bubbles, five bubbles. You must introduce the bubbles in pairs because when they are in pairs, you can cancel them out. So here, this introduce one bubble here, one bubble here, doesn't change the value. Introducing one bubble here, one bubble here, doesn't change the value. Yeah? So then what? This is already none. G2 is already none. G3 is already none. G1 is actually none, but it is dual symbol. So now you have 3 NAND. But remember I told you, AND or logic, you can just straight up convert it to NAND gate. Same number of gates. They are the same. Either introduce the bubble or you introduce the bubble from NAND or NOR, universal gate, to basic, you cancel bubble. Okay, but if you go the other way, you introduce bubble. That's the step there. So what is this? Converting post circuit to NOR only. Same thing. If you understand SUP and NAND, same technique for post circuit to NOR gates only. Universal gate. Introduce bubble. Now this becomes NOR. Ta-da! Alright. Introducing cancelling. I'll show you now a systematic way of cancelling and introducing, because you have many gates, so how do you know which gates to convert to its dual symbol? Look at this example. First thing, you need to know how to draw the circuit. Look at this circuit. Let me show you one thing. Look at this drawing here. I am sure quite a number of you actually draw EF at the beginning straight up, same level with AB, because they are the input, right? A, B, C, D, E, F. However, this is wrong. I mean, it is not actually wrong. The input is A, B, C, D, E, F, and the output is correct. But as a computer scientist, as an engineer, electrical engineer, you don't draw it this way. How do you actually draw it? If we try to get the mathematical equation, the Boolean expression, we write from, what is this, left. We write from the left. But when we draw from the right, from the end, from the output here. We go this way. So what do I mean? So you start with the output here, and then you draw the input for the first wire. So you got your D and ABC bar there. That means the other wire must also be in the same level. That's why DEF has to be in the same level. You cannot put EF at the end at the start with AB. Yeah, so always start from the right. Okay, right to left. When we draw from right to left. So once you have this, your drawing is correct. So this is not the best way of doing it. Next, you need to label the level. So now you already have it. Okay, so you start with odd. Yeah, so start with from the. You can start either way, but let's start from the end. So odd, even, odd, even. Right? Odd, even. Okay. So this slide starts from the right, odd, even. Then the next thing you need to do is choose one level. You can choose even, you can choose odd, but I usually always start with whatever the level of my last gate, my output gate. Okay, in this case, this is odd level. So I'm going to choose odd level. Then what do? I will convert all the gates in the odd level. So this odd level and this gate in this odd level, I will change it to its dual symbol. Okay, so I'm choosing this odd and this odd. So that too will be changed to dual symbol. Right. So now we have all this bubble. What we need to do is cancel the bubble that meets here. Alright. Let me draw. However, whoops, wait a minute. This looks weird. This one. Are you going to draw it this way? One bubble only? Definitely not. So what you do is you convert this bubble to this way. Yeah, convert the bubble to a proper NOT gate. Okay? So I repeat. Make sure your drawing is correct. Okay? You must start from the right, then draw towards the beginning, and then find the level, odd, even, choose one level. I always choose the one, the last gate, yeah, with my last gate is odd, so in this case I'm going to choose odd. I change both or all. In this case I have only 2 odd levels. If I have 3 odd levels, 4 odd levels, change all the odd levels, the gates in the odd levels to its dual symbol. Then cancel out the bubble. And then if you have one single bubble, change it to a proper NOT gate, redraw it. You have your final answer here. Sorry, just now. Okay, so this is another example. In this case, it's already saying choose the odd level. So what is the solution? Yeah, to get the Boolean expression, change the odd level. Why? Because odd, even, odd. So I say I'm going to choose odd, right? I mean, I'm going to choose the last gate. So in this case, I'm choosing odd. Yeah, change the odd here, change the odd here. So I cancel. Then I will get the final answer. Trace it from AB. Yeah, so this is A bar plus B bar, D bar plus E bar. Right? Since I already cancelled the bubble, I can also cancel this long bar. I can cancel this long bar, and then I just plus it. See how easy to get the final answer. Yeah? So this is exercise, but now using even level. I told you most of the time I will use the final gate, but we can change our question. We ask you to use even level. Yeah, so change the even level. So in this case, we are cancelling this. All right. So trace the answer from the input. Okay. Look, your actually, if you trace, you will get this answer. But that is not the last answer, isn't it? Because you have a long bar there. I told you, yeah, the simplified answer must have single bar only on one variable. So you have to do further simplification, yeah, with your De Morgan, and maybe if you need rule, algebra rules. So this is why I choose the last level, the level of my last output, my last gate. That's why I choose odd. See, when I choose even, it is not simplified because you still have this bubble at the end, and that bubble means long, long bar. Yeah, because it's at the last gate. That's why I change the last gate. I don't want to have bubble at the end here. Okay, so the best way is choose the level of your last gate. Then you straight away get the answer like the previous example. In this example, when we change even level, you have to do extra steps. This is using more. Same thing, yeah, you can trace it and try using your knowledge from the NAND example and see whether you can solve this. Same thing, yeah? Odd, even. So I'm going to choose odd because that's the last one. So that's why I changed the odd level. So okay, look at this example. Implement the expression with NOR logic using appropriate dual symbol. As usual, draw it first. Basic gate. Or. And then N. Okay? And then what do? Introduce bubble. We just play around with the bubble. Now you have this, we know that this is actually NAN. Is this negative N means this is NOR. And this is already NOR. This is already NOR. So you already have 3 NOR. Here. Yeah? So this is already NOR, this is already NOR. You convert this to NOR. So this is your answer. Okay, you implement it. Convert the NOR only circuit to equivalent circuit using dual symbol. Prove that the two circuits are equivalent. Odd, even, odd. Even if the question doesn't ask me to use odd, I will definitely use odd. So I'm going to change the odd to its dual symbol. Change to dual symbol. How does this dual symbol looks like? There you go. Yeah? So please try this. This is the solution. Please have a look and make sure you understand how it's done. So with this, you can cancel, which actually in the drawing itself, you can cancel. Either you cancel in drawing or you cancel in the expression. So double bar, cancel it out. Then you get your final answer. Easier. Yeah? When you use odd number, very easy to get the answer. So this is extra exercise question. Please try it. But this time try even level. I bet you have to do extra steps. Just like the other example in the NAND gate. There's your answer. See? I told you. Why do we need all these extra steps? Don't want. Please don't. Yeah, make sure you use the correct level. So you have all these extra exercise 5.7, 5.8. I do hope you attempt them. Compare your answer with your friends. Alright, so that's the end of our, what topic is this? Dual symbol. Alright, so you have learned from the beginning the AND OR logic, and then AND OR invert logic for post, and then we go to universal gate with NAND and NOR, how to convert each basic gate using universal gate, and then that universal gate NAND and NOR has its dual symbol, which you can use, yeah, as an alternative way to simplify your circuit without going into the Boolean algebra, without going into the equations. Just from the drawing, from the circuit, but make sure you draw the circuit correctly. Start from the right, from the output, and then find your level, choose your last level, convert it into dual symbol. Either introduce bubble or cancelling out the bubbles. That one you have to practice a lot. So in our last video next, so we have 4 parts, will be our problem statement where you're going to design a combinational circuit, yeah, with an example, a real life example. Okay, your chemical engineering plant, your car alarm. So I'll see you in the next video. Bye!